Hello, my dear students. Welcome to IMS Gate Academy. Myself, Vipin Mishra, the lead mentor at IMS Gate Academy. I welcome you all in this score booster series of IMS Gate Academy. So we already started this series, and Jayaprakash sir has covered the subjects networks analysis and digital electronics. And today I am going to cover signals and systems. So we are going to have two sessions in this subject, signal and system, the part 1 and part 2. We will cover some topics and some questions in part 1 and followed by the part 2, which will have the other topics and other questions, right? And after that, in this month only, we are going to cover control system part 1, part 2 also in this score booster series. So I hope that you people are enjoying this score booster series. In the recent past, all the gate aspirants of EC electrical and instrumentation were greatly affected, and they have scored many marks after attending this score booster series of IMS Gate Academy. And this year also, if you will follow the same series, it is going to increase or it is going to boost your marks in the upcoming gate exam. So let's get started with the subject signal and system. So I'm going to discuss almost around 45-50 questions in this particular sessions. We will be having part 1 and part 2, right? So there will be two sessions. Whatever questions I'm going to discuss, I will tell you the concepts related to those questions, the important formula and important tricks and tactics also, right? Practice these questions and definitely you are going to boost your score. So these series were very much helpful for the students of gate 25, 24, 23, and these are going to be very much helpful for you people also. So let's get started. Before starting, I would like to request you that join our Telegram channel so that you will regularly get the updates related to gate exam and whatever we are doing, right? Now, so this is going to be the first questions. This is going to be the first question that we are going to discuss in signals and system. Okay, so what is this question? Let me read it. We have been given XT and HT of an LTI system as follows. Then what is going to be the output? The input to the LTI system XT is given. The impulse response of the LTI system HT is also given. Now what is going to be the output is what you have to calculate, right? So for an LTI system, you know that output, for an LTI system, you know that the output is convolution between the impulse response and the input, right? Now look at the input. The input is given in terms of the impulses. So we can write the given input in terms of impulses, and it is an impulse at t equals to 0 having magnitude 1, and it is having an impulse at t equals to 1 having the weight of -1. So we can write it del of t minus 1, right? Need not to express HT, right? Don't get into the trap, need not to express HT, right? Without expressing HT, we can solve this question. How? Just see. So HT convolution del t minus 1 we are having. Now you know that convolution of any signal with impulse results in the same signal. So what is going to be the result of this convolution is, it is going to be h of t. When we will convolve h of t with del of t, we are going to get h of t minus, when we will convolve the h of t with del of t minus 1, it will give us h of t minus 1. So we are going to get the output as h of t minus h of t minus 1. We can also write it that it is h of t plus minus of h of t minus 1, right? Now see that h of t is given to us, right? If I draw the h of t, so see h of t is given to us, and what is h of t? They have given h of t a triangular pulse like this, okay, from 0 to 1. This is h of t. Now we need minus of h of t minus 1. So what will be h of t minus 1? You need to shift it by 1 on the right side, right? So this will be h of t minus 1. So when you will shift it on the right by 1, coordinates will become 1 and 2, the magnitude remains same. So this is going to be h of t minus 1, right? Now to get h of minus h of t minus 1, you need to reverse this signal. Okay, you need to reverse the amplitude of this signal. So it will become a signal like this. From 1 to 2, the magnitude will become plus, and it is minus of h of t minus 1, right? So now we have the signal h of t with us. Now we have the signal minus of h of t minus 1. Now we have to add them, correct? So if we are going to add these two signals, just see, if we are going to add these two signals, what we are going to have will be known as the output. So what we are going to have is this signal. Just see, this is h of t from 0 to 1 like this, okay? Now add minus of h of t minus 1, so you will get a signal like this, correct? This is going to be the output, right? This will be our output y of t, which exactly matches with the option given as option number A. So option number A is going to be the right answer, correct? This is how you can solve this question. Now don't get into the trap where you are writing and you are expressing the signal ht. Need not to do that, right? We have been given the signal xt, which is in the form of impulses. So write that signal. After writing the signal xt, just do the convolution of it with ht, okay? And you know, convolution of any signal with impulse results in the same signal. In that way, you will get h of t minus h of t minus 1, whom you can write like this. H of t is given, now get minus of h of t minus 1. Add this signal, and that is going to be your signal yt. So in this way, you could have solved this question easily. So this question gives you a very important concept, how to do convolution of two waveform. Need not to think a lot, right? Sometimes there is some hidden tricks, you have to identify those, correct? Now let us see the question number 2. Now see this question. In this question, what they are saying is that pick the correct option based on the statements. Statement number A is the system yt equals to xt plus x of t plus 2 is linear, time invariant and non-causal. The system yt equals to t minus 2 x of t plus 2 is time variant, non-causal and stable. This is option B. Option number C is system yt equals to e to the power xt. Xt is non-linear, time invariant and memoryless. Option D says the system yt equals to integral xt dt is stable, okay? When it comes to linearity, when the system is linear, then there should be no non-linear operator operating on x and y, right? If the system wants to be linear, there should not be any non-linear operator operating on x and y. So based upon that, if we see this system, so this is normal yt equals to xt plus x of t plus 2. So there is no non-linear operator operating here. So this is linear, right? This is linear. Here if you see again, there is no non-linear operator operating here on x and y. So this is also linear, right? Here can you see any non-linear operator operating on x and y? So here you have e to the power xt, right? So exponential operator is operating on x and y. So this is non-linear, okay? Here we don't have to comment about linearity, but the integrals are linear operator, okay? And what we can see that on x and y, there is no non-linear operator, correct? Now when it comes to time variant or invariant, there should not be any operator operating on t, right? There should not be any coefficient of time present in the input-output relation, correct? And there should not be any kind of reversal or time scaling should have been done on t, right? Now see, so what we can see here, this is xt x of t plus 2. No coefficient of time and no operator operating on time, or no scaling or no reversal is done. So this is time invariant, correct? Similarly, if you see here, we have coefficient of time present here. So this is going to be time variant, okay? Now if we see this question, there is nothing happening with t here, no coefficient of time present. So this will also be time invariant, right? Now if we see here, integrals are time invariant operator unless there is something happening with t. means t is being scaled reverse or any operator is operating on t. So nothing like that is happening. This is also time invariant. Correct. Causal, non-causal, right? So if you have to tell about causal, non-causal for normal system, output should depend upon the present and past values of input. It should not depend upon the future values of input, right? So here what you can see, we are doing t plus 2. T plus 2 means you are going to tell the future. So this is non-causal. Okay. Here also we have t plus 2. Because of this t plus 2, this will also become non-causal, right? Here there is nothing happening with the t, so this is causal. Correct. Integrals. Integrals will be telling us from the past to the present value, so they are also causal, right? Now see which statement is correct. So in statement A, they are saying it is linear, time invariant and non-causal. Yes, this is correct. Here they are saying that it is time variant, it is non-causal and it is stable. So comment about the stability of this also. We left the stability. Bounded input, bounded output stability, we have to comment here. Even though you are choosing xt to be stable, output also depends upon t minus 2, where t can have any value. If t will become infinite, output will also become infinite. So this is unstable, right? So this statement is correct? No, this is not correct, because this is time variant, this is non-causal, but this is not stable. If I see statement number C, they are saying it is non-linear, it is time invariant, and it is memory-less. Memory-less means it is static, right? So static or dynamic, how to see? Have a look over T. So everywhere you will see T is a plain T. Neither shifting, scaling, reversal, no operator is operating on T. So this is memory-less. Memory-less means it is static. Okay, so whether this option is correct, it is non-linear, it is time invariant, and it is memory-less. Yes, this is correct. Right? If this is correct. But they are saying memory-less. Memory-less means, yes, this is memory-less, right? Now, see about this option. So the system is stable. Yes, this is stable, isn't it? Linear, time invariant, causal, and this is stable. Sorry, this is unstable. Integrals are unstable operator, right? Integrals, this is non-causal. Sorry, this is causal. This was linear, time invariant, causal, and this is unstable. Okay, and this is memory-less. Correct. So is this stable? No, this is not stable. Integrals are unstable operator. Right. So option A and option C is going to be the correct option. Got it? So remembering these properties, you can solve these questions. For linearity, what you have to see? For linearity, you have to observe that is there any non-linear operator operating on x and y? If it is, system is non-linear. Otherwise, system is linear. If you have to see time variant or invariant, if there is operator operating on t, if there is scaling done, if there is reversal done on t, if there is coefficient of time present on t, in input output relationship, system will be time variant, right? If you have to see causal, non-causal, output should depend upon present and past values of input. It should not tell future, right? Means there should not be any scaling, there should not be any reversal, there should not be positive time shifting, +2, +3 type of things should not be there. If you have to see stability, right? Bounded input, bounded output stability is being discussed here. So if you are giving bounded input, output should be bounded also, right? Integrals are unstable operator, correct? So this is how, remembering these facts, you can solve this question. I hope it is clear. Now see the next question. The graph shown below represent a waveform obtained by convolving two rectangular waveforms. Okay, so this waveform is a result of convolution of two waveforms. Okay. Then what will be the duration of the two waveforms? The two waveforms are having duration of 4 units each. 4 and 2 units, 6 and 3 unit, 6 and 2 unit, right? Convolution of two rectangular pulses of unequal duration is a trapezoidal pulse that we are getting here. Okay, convolution of two rectangular pulses of unequal duration is a trapezoidal pulse. So see, convolution of two rectangular pulses of unequal duration will be a trapezoidal pulse. So when you are getting a trapezoidal pulse like this that we have here, okay, or I can draw it here only, need not to draw it separately. So just have a look. Convolution of two rectangular pulses of equal duration is a trapezoidal pulse, okay, where this will be the duration of the first pulse and this will be the duration of the second pulse, right? This you can call as T1 and this you can call as T2, right? Where T1 and T2 are the duration of the first and the second pulse. Convolution of two rectangular pulses of unequal duration is a trapezoidal pulse that we are getting as result, right? Now what were the duration of those two pulses? So in this trapezoidal pulse, this tells us the duration of one pulse and this distance tells us the duration of the other pulse. Okay, so looking into these facts, tell me what is T1? T1 is -4 to 2, that is 2, and what is T2? T2 is from -4 to 2, so it is going to be 6, right? It is going to be 6. So what will be the answer? 6 and 2 units respectively. Okay, 6 and 2 units respectively. In this way you can get the answer of this question easily. What you have to remember is that convolution of two rectangular pulses of unequal duration is a trapezoidal pulse that they have given to us. Okay, in a trapezoidal pulse, this much distance is T1 and this much distance is T2. Okay, now you can read those distances and you can easily tell me the answer. Correct? This is how you could have solved this question easily, right? Or just see, let me explain this to you. If suppose we have two rectangular pulses of unequal duration, let's suppose that this is the first pulse having magnitude A1 and let's suppose that this is the second pulse having magnitude T2, right? For example, I am taking these two pulses. If we are doing convolution between them, then the result will be a trapezoidal pulse, right? The result of these will be trapezoidal pulse. Just like this, okay? So this coordinate will be the addition of the initial values. This coordinate will be the sum of the final values, right? T1 and T2 final coordinates, not final value. 0 plus 0 will be 0. T1 plus T2 will be T1 plus T2. Now this much distance is T1 and this much distance is T2 here, right? T1 and T2. Correct? And what is this coordinate? This will be T1 plus T2. Correct? We have taken the two pulses only on the right hand side. If suppose we had some part on the left side, some part on the right side, then you will get same trapezoidal shape. Coordinates will be written in a different way. Correct? So this duration is always T1, this duration is always T2. Like that, you can judge that what is going to be the answer of this question. Remember the fact, convolution of two unequal duration rectangular pulses is a trapezoidal pulse. Okay, and how to get the magnitude? The magnitude will be A1, A2, and let's suppose T1 is less than T2 here. So whatever duration is less, we will multiply that duration in the magnitude. Okay, so A1, A2, T1 will be the magnitude. Correct? So this is the fact, right? By observing this fact, you can tell me the answer of this question. So answer D is the correct answer here. I hope it is clear. Right? Now see this question. Two continuous time signals x1 and x2 have time periods of A and B respectively. If yt is a signal formed by doing the scaling and shifting in x1 and scaling and shifting in x2, then which of the following will be one of the condition for yt to have a time period 3? Okay, for yt to have time period 3. See, x1 and x2 have time period. The time period of x1 is A, right? The time period of x1 is, let's suppose it is t1 and it is A. Okay, the time period of x1 2t plus 3 will be what? What will be the time period of 2t plus x3? Yes, what will be the time period of 2t plus s3? Let me write it t. Let's suppose, chalo t1. Then what will be the time period here? t1 dash. If I write it t1 dash, shifting does not affect the time period, but scaling affects. So scaling amount will be divided in the time period, right? Similarly, x2, let's suppose the time period is t2 and it is given b. Then what is going to be the time period of 3t plus beta? So see, let me call it t2 dash. Shifting does not affect the time period, but scaling affects. So scaling amount will be divided in the time period. Okay, scaling amount is divided in the time period. So now see, we have signal y of t, and the y of t is x1 2t plus 3 plus x2 3t plus beta. They have given the time period of yt, which is going to be 3. The time period of x1, which we are calling t1 dash, x1 2t plus 3, we found it is a by 2. The time period here is t2 dash, when we found that it is b by 3. Okay, then we know that time period t is going to be LCM of t1 dash and t2 dash, or it is going to be the LCM of a by 2 and b by 3, right? Or t is given 3, LCM of p by q and p1 by q1 or p2 by q2 is equals to LCM of a and b divided by the HCF of 2 and 3. Now HCF of 2 and 3 is going to be 1, so LCM of a and b, right, divided by 1. Up, the LCM of A and B is going to be 3. So LCM of A and B will become 3 if we have A or B equal to 3, right? We got this, that LCM of A and B should come equal to 3 as per this condition. Now it is only possible when both A and B are 3, then LCM will also be 3. Right, so this option is correct. Option number B says A is 1 and B can be any value. No, right? If A is 1, B only have to be 3, then only the LCM can be 3, so B cannot have any value. A is 3 and B is 1, so 3 and 1 will give us LCM 3. That's also right, right? Then they are saying that B is 1 and A can have any value. No, that is also not right. So only this combination can produce the time period 3, or this combination can produce a time period 3. So these are going to be the correct option. So what you have to remember is that shifting reversal does not affect the time period, but scaling affects the time period, right? And if we have two signals in addition and those two signals are periodic, the period of that combination is LCM of the period of the individual signal, correct? In this way, by remembering this small fact, you can not only solve this question, you can solve many other questions also, right? I believe it is clear. Then see the next question. Now see this one. Now it's a very good question, right? A continuous time signal is given, xt is given in terms of impulses. Then yt is integration of xt and zt is integration of y. Okay. Then the energy of y is E and power of z is P. Then what is going to be E plus P? Right? How to solve this question? So first of all, the given signal xt can be written. If I write this signal xt, this will become -2 del of t plus 2, right? We can write it x of t is -2 del of t plus 2, right? It is plus 2 del of t plus 2. It is minus 2 del of t minus 2. Okay. So this is going to be the signal x of t, right? Up tell me, yt is a signal which we are going to get when we will integrate the signal xt, right? So what we will get? Integration of impulse is step signal, right? So integrate it and what we will get is step signal. So we will get 2 u t plus 2 minus 2 u t minus 2. This is going to be y of t, right? Then z of t is integration of yt dt. Okay. So now we have to integrate this y. Now y is what? Y is basically the unit step signal. Integration of step signal is ramp signal. So we will get 2 of r 2 t plus 2 minus 2 of r t minus 2. Now this is going to be z of t, correct? In this way, by knowing this fact, you can calculate yt and zt, that integration of impulse is a step signal, integration of step is a ramp signal. Now after that, we have to calculate their energy and power. So let us draw these waveforms, because then this part will be easy. Now if I am going to draw the waveform for these two signals, yt and zt, then see what will be yt and zt. Y of t, this is y of t, okay, and this is z of t. Y of t is 2 ut plus 2 minus ut minus 2, right? So it will be like this, having magnitude 2. This is signal y of t. If I talk about z of t, then z of t will be a signal like this. See, from -2 to +2, okay, it is having a slope of 2. So see, if this distance is 4, okay, then what is this distance, so that the slope will come to? Obviously, this is going to be 8, okay, and after that you will get a signal like this. So this magnitude is going to be 8, correct? Now this will be the signal z of t, okay. In step signal, we only have to mention the magnitude and the duration. In ramp signal, we have the locations and we have to also get the slope. So what is written in front is the slope. Slope is going to be 2. So to get the slope 2, just see, total y part is 4. What should be the x part? It should be 8. Then we can get the slope 2, right? So this is going to be z of t, right? Now see, if I have to calculate that what is going to be the energy of yt, right? If I have to calculate energy of yt, which they are writing as E, right? So energy of yt is going to be, it's a rectangular pulse, and in a rectangular pulse the energy is a square b, where a is the height. So what is the height? Height is 2 and b is the width. So what is the width? The width is 4, okay. So what we will get? We will get 2 square, which is 4. 4 plus 4 is 16. In this way, you can calculate the energy of the signal yt easily, okay. Now, if I have to calculate the power of ZT, right? So, to calculate the power of ZT, what is the formula? It's a aperiodic signal, and for aperiodic signal, the formula is limit t tending to infinite 1 upon t minus t to t z of t is square dt. Correct? This is the formula to calculate the power for aperiodic signal. Now in this formula, just have a look how we can write this formula. So this formula can also be written as limit t tending to infinite 1 upon t, right, minus t. So the leftmost limit here is minus 2. So from minus 2 to 2, right, from minus 2 to 2, we can integrate the signal zt. Okay, then we can also integrate the signal. Let me write this part of signal to be z1t. Okay, then we can also integrate the signal limit t tending to infinite 1 upon t limit 2, right, lower limit is 2 and higher limit is some t, and we can write it z2t dt. Correct? So we can divide our integral like this. In this integral, you just have a look that this much part of the signal z1t is a fixed duration signal. It is from minus 2 to plus 2. So for a fixed duration signal, right, just see, this is what? This is energy. Okay, this is what? This is energy divided by time. So this quantity is going to be a finite quantity. Have a look. I'm going to get this quantity as a finite quantity. Now finite quantity, it will be a number. Now when you will put t tending to infinite, finite upon infinite will be 0. Okay, so this is going to result in 0 plus this we have to evaluate. Okay, this we have to evaluate. So if I write it here, the power of zt will become only this much thing, limit t tending to infinite 1 upon t, okay, from 2 to t. And what is the magnitude of this z2 part? This z2 part of the signal is having a magnitude 8, okay, is square dt. Now just solve it. So what you are going to get, limit t tending to infinite, 8 square will be 62, 68 square will be 64, 64 by 2t, and when you will integrate, you will get t, limits are 2 to t. Then see, limit t tending to infinite 32 divided by t, we will get t minus 2 from here. Okay, and now we have to put the limit. Okay, so when you will adjust it and put the limit, you are going to get 32, right? So just see, this is how intelligently you have to solve this to get the energy, sorry, to get the power. Okay, so we have to get that what is the sum of E plus P, means energy of xt, energy E is basically energy of Y, so energy of Y plus power of Z, what is going to be their sum? This value we have calculated 16, this value we have calculated 32, so answer is going to be 48. Right? A lot of concept has been used in this question, and that is why I have selected this question. Right? Through this question, you will be able to learn so many concepts. Any one of them will be asked, or a combination of them will be asked in the GATE exam. So first of all, you have seen that how to integrate the signals. Okay. So integration of impulse is step is ramp. By that we get yt and zt. After getting yt, zt, we have drawn the waveform. Right? After drawing the waveform, yt is a simple rectangular pulse. We have to calculate the energy. The energy of a simple rectangular pulse is amplitude square into the width of the signal for which it is existing. You will get 16, right? Now this is a aperiodic waveform whose power we have to calculate. So we will use the aperiodic formula. We can divide this formula into two steps, one from -2 to 2, another from 2 to t. From -2 to 2, this signal is having a finite duration signal. So calculation of power is basically energy upon time. Energy of a finite duration signal will be finite. Finite upon infinite will be 0. So we only have to evaluate this part, right? Which you have done like this. Okay, and after that you can add the energy and power, and that is how you will get the final answer. I believe it is clear to you. Okay, so it was a very good question. After solving this question, you will got a lot of conceptual clarity. It's a mix of a lot of concepts. Any one of them will be asked, or maybe you will be getting all of those like this. Now see this question number 6. The input and the impulse or response of LTI system are shown below, are given. So xt is given, impulse response is given. The value of the output, if A is 2, B is 5, is Y1. If A is 5, B is 5, then Y2. Then the value of Y1 and Y2 are. Okay. So if you have an LTI system, the output of the LTI system is convolution of the input and the impulse response, right? Ab input is e to the power minus ATUT, output is e to the power minus BTUT, right? So remember few formulas. Convolution of e to the power minus ATUT with e to the power minus BTUT is e to the power minus AT minus e to the power minus BT upon B minus A U of T, right? And convolution of e to the power minus AT with e to the power minus ATUT will be T e to the power minus ATUT. Convolution of e to the power minus ATUT with only UT, means B is 0, will give you 1 upon A e to the power minus ATUT. Correct? Remember these three important formulas. Remember these three important convolution results. Okay? If you can practice these three results, you can solve questions like this very easily. Correct? So in case number 1, when A is 2 and B is going to be 5, right? So what will be Y1t? Y1t will be convolution of e to the power minus 2t ut and e to the power minus 5t ut. So it is going to be e to the power minus 2t minus e to the power minus 5t divided by B minus A, and that will be 3. Correct? So this will be your Y1t. Now when A is 5, B is also 5, right? When A is 5, B is also 5, then they are saying it to be YT. Then e to the power minus 5t ut convolution e to the power minus 5t ut is going to be what? As per this formula, it is going to be t e to the power minus 5t ut. So these two are going to be the right answer, which are given in option number A and option number, not in option number A, they are given in option number B and option number D. Correct? So if you know these formulas, if you can practice these formulas, it is very easy to get the answer, right? And if you don't know, then you have to do the graphical convolution. Okay, that is also not a tough part. If you have learned signal and system, you can easily do that, but you can save a lot of time if you have practiced these formulas, right? Correct. So I hope that this question as well as its solution is clear to you and you have learned some very important tricks here. right? Now, moving to the question number 7. Now see this question number 7. It's a very good question. Nicely framed. The even component and the odd component of a signal is given. The energy of the signal, energy of this signal will be what? Okay. So first of all, you get the signal xt, which will be even part of the signal plus odd part of the signal. Okay. So we need to add the even part and odd part of the signal and we will get the signal xt, right? So just add them. How to add the signals? So have a look. At -1, so think about -1. At -1, this signal is having a value 1/2. This is having a value -1/2. If we are going to add, we are going to get 0. Okay. Then see at 0. At 0, this is having a value 1 and this is having a value 0. 1 plus 0 will be 1. Okay. 1 plus 0 will be 1. So from here we have to move to 1. Right. Now at this point, it has a value 1/2. It has a value 1/2. 1/2 plus 1/2 will be 1. So at the point 1, we will be 1. Right. After that, there is no existence of the signal. Okay. After that, there is no existence of the signal. It is only existing from -1 to +1. So you can see this signal is neither even nor odd. That's why they have resolved it into even and odd components. So this is how you will get your original signal back. Okay. This is your signal x of t. Correct. Now if I calculate that what is going to be the energy of xt. So energy of xt has a formula -infinite to infinite x of t is square dt. Okay. But you don't have to apply the formula. Applying formula and then calculating will take a lot of time. Okay. So see, let's suppose that I am dividing this signal into two parts. This part is having energy E1, this part is having energy E2. Okay. So total energy is the sum of E1 plus E2. Now E1 is the energy of a triangular pulse. So energy of a triangular pulse of this kind is equals to A square B divided by 3. E2 is the energy of the rectangular pulse. The energy of the rectangular pulse is A square B. What is A? A is the magnitude and B is the width, right? So see here. Here what is the magnitude? Here if you see, the magnitude is 1. 1 square into what is the width of the signal? It is also 1 divided by 3. Here if you see, the magnitude is 1. 1 square, right, into B. Width of this E2 is also 1. So you will get 1/3 plus 1 or 4/3. 4/3 is the energy of the signal xt. But we don't have to calculate the energy of signal xt. We have to calculate the energy of another signal f of t, which is being framed by -x minus 2t plus 3. Okay. So shifting and reversal does not affect the energy, but scaling affects the energy, right? So scaling affects the energy. So energy of the signal ft will be, see, signal xt energy, you know. Now this signal is being scaled and it is shifted also. Shifting does not affect, but scaling affects the energy. And magnitude is also reverse, right? What is magnitude? -1. So what will be the energy? Magnitude is -1. So this -1 square, right? And energy of xt divided by the scaling amount, right? This is what we will do. So what you will get is 4/3/2 or simply 2/3. Is that clear? So we have multiplied the magnitude by -1. Whatever is being multiplied in magnitude, that will be squared, right? Shifting does not affect the energy. Scaling is divided in the energy. Like that you will do and you will get your energy of this particular signal. Right? I hope that it is clear. So now through this question also you have learned some very important and good tricks. If we have a triangular pulse like this, so like this, if we have a pulse, energy is a square b by 3. If we have rectangular pulse, energy is a square into b. How is scaling, shifting, reversal is going to affect the energy? How the magnitude scaling is going to affect the energy? This is how you have seen it, right? So again, you have learned a very important concept which might be useful in scoring marks. Correct? So I hope this is clear. Moving to our next question. Now have a look over this question. Question number 8. Continuous time signal xt is represented by, what is going to be the fundamental time period for this signal? Okay. So have a look here. What is the frequency omega 1? It is 2 pi. What is the frequency here omega 2? It is pi over 0.3. What is the frequency here omega 3? It is 3 pi over 5, right? So if I ask you that what is going to be the time period t1, it is going to be 2 pi by omega 1. So 2 pi by omega 1 is 2 pi, so we will get 1. What is going to be the time period t2? It is going to be 2 pi upon pi by 0.3, right? Or what we will get? We will get pi by 0.3, pi will cancel, 0.6, or we can write it 6 by 10, or we can write it 3 by 5. Correct. Then if I calculate that what is going to be T3, then it is going to be 2 pi upon omega 3, and 2 pi upon omega 3 is 3 pi over 5. So what we will get? We will get 10 by 3. Right? These are going to be the time period. So if I ask you that what is the time period of xt, then it will be LCM of T1 and T2 and T3. So LCM of what is T1? It is simply 1 by 1. T2 is 3 by 5. T3 is 10 by 3. So it will be equal to LCM of 1, 3 and 10, and it will be HCF of 1, 5 and 3. So LCM of 1, 3 and 10 will be 30. HCF of 1, 5, 3 will be 1. So what we will get is 30. Right? We will get 30. Okay, then what we have to tell? We have to tell the time period of this signal. Now we have calculated the time period of xt. Now they framed another signal yt, which is minus of x minus t plus 2 plus x of 2t minus 3. Okay. So what they have done here, in the same signal xt, they are doing shifting and reversal. Shifting and reversal does not affect the time period. So the time period here will be 30. Okay. And what is happening here? Here your xt is shifted and scaled. Scaling affects the time period. So here the time period will be 30 by 2 or 15. Then what is the time period of yt? Is going to be the LCM of 30 and 15, and LCM of 30 and 15 is 30. So answer will be 30. Correct. In this way you can solve this question. Tell me guys, I hope it is clear. Okay. So you will calculate the individual time periods. Okay, just cross check the calculation. I hope I have done everything right and this is going to be the answer. So in this way you will calculate the individual time period, then you will take their LCM and you will find the time period of your given signal, right? Then given signal, now the time period of yt which we have to calculate is obtained by scaling and reversing and adding the signals, these two signals. Okay. Here you have done shifting and reversal, that does not affect the time period. Here you have done shifting and scaling. Scaling affects the time period. Time period will be divided in scaling. Sorry, time period, scaling will be divided in time period. I just spoke in the reverse thing. So it will be 30 by 2 here. Now time period of yt will be LCM of 30 and 15. That will give you 30. Right? So in this way you could have solved this question. I hope it is clear. Right? Now have a look over this question. What is given here is the impulse response of a continuous time signal is h of t equals to rt minus 2 plus 2 ut minus 3, 6 ut minus 4, 2 rt minus 4 minus 2 rt minus 5, where rt and ut are ramp and step signal. Input is ut minus 4. Then what is going to be the output at t equals to 2? Output at t equals to 2 we have to calculate, right? So we have an LTI system, right? In an LTI system, what is output? In an LTI system, the output is convolution between the input and the impulse response. Okay. Now both the input and the impulse response are given. Let us draw their waveform first. So if I draw the waveform of the given ht, so have a look over this given ht. It is rt minus 2. So this is rt, this is rt minus 2. Okay. So 0 and 2, rt minus 2. What is written in front of is the slope. If this is 2, to get the slope 1, this magnitude also has to be 2. Okay. This magnitude also has to be 2. Right. rt minus 2. Then the signal changes at 3. At 3, it is having an step which is having a magnitude of 2. So from here we are moving 2 up. So this will be 4. Okay. 2 ut minus 3, and then the signal changes at 4. Okay. So it remains 2 ut minus 3, and at 4 it is going minus 6 down. So you are already at 4. You have to go 2 more down, then you will reach to the 6. Correct. Now 6 ut minus 4, right? 6 ut minus 4 you got, and after that immediately it takes the shape of ramp again up till 5. Right? Slope is 2. So see, y is 2 and x is 1. 2 upon 1 is 2. So slope is 2. So this is how from the given ht you can draw the waveform. Right? So this is going to be the waveform of this signal h of t. Now if h of t you have obtained, then they have given you x of t also. Okay. Now what is going to be x of t? So have a look. X of t is given ut minus 4. Ut minus 4. Right. This will be x of t. Magnitude will be 1. X of t is u of t minus u of t minus 4. Okay. Correct. This is x of t. Now what we have to calculate here? Just see what we have to calculate. We have to calculate y of t, which is going to be x of t convolution h of t. Right. Now if you are going to do their convolution, what you can see is it's a very difficult task, right? So use the formula. As per the formula, this will become minus infinite to plus infinite h of tau x of t minus tau and d tau. This is going to be yt. We have to find yt at t equals to 2. Okay. So we are going to put t equals to 2 here, and then it will become minus infinite to plus infinite h of tau x of 2 minus tau d tau. Okay. Now we need h of tau. So what is h of tau? This is h of t, replace t with tau. So this will become h of tau. Right. This is your h of tau. Now we need x of t minus tau also. So this is your x of t. Right. Now let me write it x of tau. Replace t with tau. This is your x of tau. Correct. Now see, from this x of tau, you need to convert this x of tau into x of t minus tau. Okay, so x of t minus tau will be what? See, this is your signal. You already have your signal x of tau. Okay, so in that, first of all, we have to do the shifting of 2. Okay, so if we will shift this signal by 2, how much we are going to get? If we create x of tau plus 2, right, means we have to subtract 2 from the coordinates, then you will get minus 2 to plus 2. Clear? You will get minus 2 to plus 2. Okay, so you have created the signal x of t tau plus 2. Now you have to do reverse also. So if we do the reversal of it, then you can see that reversal is not going to affect anything. So this is going to be x of minus tau plus 2. Okay, now you already have h of tau. Okay, now I am going to draw the signal minus x of minus tau plus 2. Just see like this, right? This is what we have obtained as x of minus tau plus 2, correct? Or 2 minus tau, whatever you say. So these are the signal h of tau and x of t minus tau. Up see here, we have to multiply them. Multiply them means, multiplication in signal means we have to find their common area. Okay, so we have to find the common area of these two waveforms, right? So what will be that? So have a look. The common area of these two waveforms, or these two waveforms, the multiplication of h of tau into x of t minus tau. Let us do their multiplication. So their multiplication will be like this. Okay, their multiplication will be like this. Just see, you will get something like this. This is your signal h of tau from 0 to 2, and this is your signal x of minus tau plus 2. Okay, so in this duration it has a magnitude 1. So that magnitude 1 will be multiplied here, which is not going to affect the signal. So you are going to get this signal. Okay, this is the multiplication. Up, what is the value of this integral? This integral means we have to find the area. Okay, now you have calculated this signal h of tau x of t minus tau. Now the value of y of 2 is nothing but the area of this waveform. So what is going to be the area of this waveform? 1 by 2 into height into width, or you will simply get 2, and that is going to be the answer, right? GATE authorities have asked many questions like this, and that is why I also have selected this question. I hope it is clear to you. Is that clear? Don't drag yourself in calculating it through the, don't try to do the convolution between individual signal. It will be very tough for you, right? Use this trick and you can easily get it done. Don't touch h tau, okay, and get x tau, which is very easy. After that, get this signal x of minus tau plus 2, shift it plus tau, and then reverse it. You will get this signal. Now multiply this signal and this signal. And we don't have to multiply for all the values of t. They have given that you only have to calculate for y2. From there, we got an inspiration and got minus tau plus 2. So see, we have multiplied these two signals. This signal and this signal have a common area from 0 to 2, where it has magnitude 1 and it is a triangular signal. We will get a triangular pulse here. Okay. Now calculation of this integral is nothing but finding the area of this multiplication. Area of this multiplication will be 2, right? In this way you can solve this question easily. I hope it is understood. Okay, it was a very good question. Practice this question again, and there are high chances that you will get it back. Now see this question. Why I am having so many questions from energy, power and convolution? Because these are, and time period, because these only are the important topics. right? You will get questions from these topics. A continuous time signal is expressed, then what is the power of x square t? So you have to do x square t first. Yt is given. What will be x square t? X square t means sine pi by 5t plus cos pi t square. Now do the square. What you will get? Sine square pi by 5 cos square pi t plus 2 sine pi by 5t and cos of 5 pi t, right? Now sine square and cos square can be expressed in their formulas. Okay, so what is the formula for sine square? You can write it 1 minus cos 2 pi by 5 into t divided by 2, right? Similarly, you can write it 1 plus cos 10 pi t by 2, right? And then we have 2 sine a, we have 2 sine a cos b, which will be sine a plus b and sine a minus b. So once you have to add them, once you have to subtract them, right? Sine pi by 5 plus 5 pi t sine 5 pi minus pi by 5 t. Okay. Now do this exercise, and after that what we will be getting is that y of t is 1 by 2 minus cos 2 pi by 5 t by 2, okay, and 1 by 2 plus 1 by 2 cos 10 pi t, right, plus sine, that will give me 26 phi by 5 t plus how much I will get from there? I will get sine I will get minus sine 24 pi by 5 t, correct? Now if I have a constant signal, then power of it is amplitude square, the square of this constant signal. If I have a sine omega naught t or cos omega naught t, then what is the power of this? It is a square by 2. Okay, so what will be the power of the signal yt? Power of this signal will be 1 by 2 square, okay, plus 1 by 2 square by 2, right? Plus minus does not matter in between the signal, okay. Here again it will be 1 by 2 square, then 1 by 2 square by 2 plus 1 square by 2 plus 1 square by 2. Okay, so how much you will get? 1 by 4 plus 1 by 8 plus 1 by 4 plus 1 by 8 plus 1 by 2 plus 1 by 2. Right? So just solve it. How much we are going to get? We are going to get 2 by 4 plus 2 by 8 plus 2 by 2, or it is 1 by 2, it is 1 by 4, it is 1, right? So if I take 4 LCM, I'll get 2 here, I'll get 1 here, and I'll get 2 here. Sorry, I'll get 4 here. So I will get 7 by 4 as answer, and 7 by 4 is 1.75. Correct? So this is how I will solve this question. Okay, what you have learned? The power of constant is magnitude square. The power of sinusoidal signal is RMS square. What is RMS? A by root 2. A by root 2 square will be A square by 2. Okay. this is how we can solve this question. It is also very important question. Everybody knows individual signal, but if suppose we are doing any operation on the signal, you need to convert the signal into individual sine and cosine, and then you can get the power, right? So I hope this question is also clear. Now have a look over this signal. This is the last signal from this particular topic. Continuous time signal xt is given, so it is an impulse signal. Yt is an integration of it, and energy of yt, energy of y alpha t plus 3 is geometric mean of energy of y bt and y t plus 3. Then which of the following is true? You don't have to do any operation on the signal, okay? Energy of yt, right? What is the energy of yt? Energy of yt is going to be E. Then what is going to be the energy of y alpha t plus 3? Energy of y alpha t plus 3 will be E upon alpha. Then what is going to be the energy of y of beta t? This is going to be E over beta. What is going to be energy of y t plus 3? It is going to be E. Energy is only affected by scaling, nothing else. Correct? Now what they are saying is that energy of yt plus 3, energy of yt plus 3 is E by alpha, is the geometric mean of energy of y beta t, which is E by beta, okay, and E y t plus 3, which is E. It is geometric mean of these two, okay. Then you can write it E upon alpha is equals to under root E square upon beta, or we can write E square upon alpha square is E square upon beta, or alpha square is beta, or beta is under root of alpha, right? So see which option is correct. Beta is square root of alpha, right? Beta is square root of alpha, or alpha is square root of beta. What will be correct here? E by alpha square is E square by beta. E square by alpha square, so alpha square will be beta, right? Or we can write, we can write alpha to be under root of beta, okay? So alpha is square root of beta, and option C will be correct, okay? We have not done anything with the signal. What properties we know, we just have resolved those properties and we got it done, right? So in this way we can solve this particular question also, okay? Now, all these are very important and very good questions, okay? Now see the next one, question number 12. It is from Fourier series. The complex exponential power form of Fourier series is given like this, and this is the signal given. If xt is shown in the figure, then the value of Fourier series coefficient Cn will be. Guys, the given signal is what? The given signal is an impulse train, okay? Impulse train. So Fourier series, we have impulse train, correct? Impulse train can also be written as k equals to minus infinite to plus infinite del t minus kt naught, okay? And Fourier series coefficient, Fourier series coefficient of impulse train is simply 1 upon t naught, okay, where t naught is the time period. So what is the time period here? Time period here is 2. So what will be the Fourier series coefficient? Cn or Ck, whatever you write, it will be 1 upon 2, or it is 0.5. Very simple, right? So this is how you can solve this question in seconds only. Fourier series coefficient of impulse train is 1 upon t naught, where t naught is the time period, okay? Provided that the magnitude here everywhere is 1. The weight assigned to the impulses are 1 here, okay? If this weight is not 1, if this weight is not 1, then it could have been A upon T naught. If this weight is not 1, then it could have been A T naught, where A could have been the weight assigned, right? So 1 or A, whatever is given, based upon that you can get it. Okay, so this is how, this was a very easy question. You can make it easy for you if you remember this fact, otherwise it will become tough. Okay, now see this question. The Fourier transform of e to the power minus pi t square is e to the power minus pi f square. Then what is going to be the Fourier transform of e to the power minus alpha t square? E to the power minus alpha t square. Okay, now I can sense something here, that if xt has Fourier transform x of omega, then Fourier transform of x of at is 1 upon a x of omega upon a, right? The scaling property. So e to the power minus pi t square, you know, right? Now they have given e to the power minus alpha t square. So e to the power minus alpha t square can also be written in this way, that it is e to the power minus pi under root of pi by alpha, or under root of alpha by pi, not pi. You have to think that how scaling, you can make it look like that scaling is done. So if we do alpha by pi, okay, and t and a square, is that the same thing we are going to get? If we square it, pi and pi will be cancelled, so it will be alpha t square. Okay, so we can write it. Up now see what we have done. We know the e to the power minus pi t square Fourier transform. Now just see, we have multiplied t with some factor a, right? We have done scaling right now. So what will happen with the scaling? This is the factor, this is the scaling factor. So scaling factor will come like this, 1 upon the scaling factor, and whatever Fourier transform we have, right, frequency will be divided by the scaling factor, just like this. So what we will get, you will get pi over alpha, under root pi over alpha e to the power minus pi, right? You can write it under root pi over alpha into f is square, and then pi upon alpha e to the power minus pi by alpha f square, okay, or under root pi over alpha e to the power minus pi square f square by alpha, right, which is exactly given similar to option number B, under root pi over alpha e to the power minus pi square f square by alpha. So you have to sense that scaling property is being used here. E to the power minus pi t square is written, and it is now being transformed into alpha t square. So from that, how we can get it? So definitely by doing some scaling, some multiplication by some things. Okay, so you have to sense the scaling out of this function here, and that will give you the correct answer. Clear, guys? Okay, so this is how we can solve this question related to scaling. Scaling is a very important concept in Fourier transform. It has given question many times. Okay, so practice a question like this. Now see this one. Fourier transform of a signal is given. Signal is e to the power minus t modulus t, and Fourier transform is 2 upon omega square plus 1. Then Fourier transform of some function 4 cos 2t upon t square plus 1 will be what? Okay, so see, forget about everything. Remember one thing, whenever you will see sine and cosine in signals, you have to break that into their exponential formula. Remember this thing, right? So we can see we have sine cosine here, 4 upon t square plus 1 cos 2t, right? So you can write it 4 upon t square plus 1 and cos 2t will be written e to the power, sorry, cos 2t will be written e to the power j, e to the power j2 and e to the power minus j2t, right? E to the power j2t plus e to the power minus j2t divided by 2. Whenever you will see sine, cosine, break it into exponential formula. That is what you have done. After doing this, it will become 2 upon t square plus 1 e to the power j2t, okay, plus 2 upon t square plus 1 e to the power minus j2t, right? Now we have to find the Fourier transform of this, right? See, we can use the given data. So see what they have given. They have given that e to the power minus modulus t has Fourier transform 2 upon omega square plus 1, okay? Now what they have done, they have written here t in place of omega and they are asking that what is going to be the Fourier transform, okay? So what they have done, they have replaced t with omega. So what you will do, write here 2 pi, okay, and they have written t in place of omega. You will write here minus omega in place of t. So e to the power minus modulus of omega, right? This is how you will apply the duality theorem. This is known as duality, correct? You know that this is the Fourier transform of any function. Now they are being clever and they have replaced omega with t and they're asking the Fourier transform of the function. So what you have to do, you write 2 pi here and you replace t with minus omega. That's it, okay? So now 2 upon t square plus 1 has Fourier transform 2 pi e to the power minus modulus of omega. Inside the modulus minus omega is omega only. Now see, we have to find the Fourier transform of 2 upon t square plus 1 e to the power j2t. So what we will do, we will do frequency shifting. It will become omega minus 2, right? Similarly, if I have 2 upon t square plus 1 e to the power minus j2t, then it will become 2 pi e to the power minus omega plus 2, right? So you have calculated the individual Fourier transform, okay? Now we have to add them. So if you are going to add them, what you are going to get? Tell me guys, if you are going to add them, what will be the answer? Final answer will be this one, right? Just add them together, 2 pi will be common and this is going to be the answer, right? So remember one fact, that wherever you have seen sine, cosine, you have to replace them with their exponential formula, right? Remembering this, you can easily solve this question. I hope it is clear, okay? Now see the next question. So this is question number 15 and what we have in this question is, an LTI system is having impulse response which is h of t equals to 8 sample 8 t upon pi. The input applied is like this, then what is going to be the output? How to solve questions like this? Before that, before solving questions, just see what is given as h of t. H of t is given 8 sample 8 t over pi. Not like this, 8t upon 8t over pi. Okay, the pi is divided in the whole signal, so we can write like this. Now we can see, we have this signal which is of the form a sample kt. Okay, now if you will take the Fourier transform of this signal, then the Fourier transform of this signal is a rectangular pulse, right? Is a rectangular pulse in the frequency domain like this. right, which will have its duration from -8 to 8, okay, and the magnitude will be a pi over k, right, where this is your a, chalo, let me write it once, okay, because maybe you will not get a clarity, so let me write once. If I have a sample kt, right, then the Fourier transform of a sample kt is equal to a rectangular pulse in the frequency domain, right, from -k to +k, and this amplitude is being a pi over k, correct? So this is the Fourier transform of a sample signal. Now based upon that, can you tell me that h of t, which is 8 upon pi sample 8t, what will be the Fourier transform of this one? So the Fourier transform of this signal is a rectangular pulse from -8 to +8, and what is going to be a pi over k? So if I calculate a pi over k, a is 8 over pi into pi upon k is 8, so we are going to get 1, right? So this will be your h of omega. Okay, now see this question. What we have in this question is, we have an LTI system, okay? To this LTI system, whose transfer function is also given. See, this is the transfer function of this LTI system. H of omega that you have calculated has frequency -8 to +8 with magnitude 1. This is your H of omega. To this LTI system, we are giving an input x of t, and that is 4 cos 5t plus 2 sin 10t plus 3 cos 12t. Okay, so we are passing this signal through this LTI system. This LTI system is going to act as a filter. Okay, this LTI system is going to act as a filter. So what will be the output? So output will only have those frequencies which are less or equal to the frequency present in the filter. So filter has a frequency 8, right? Now those frequencies which are less than 8 will be only passed. So output will be what? So see, this is a frequency 10 here, 12 here, which is more than the filter frequency. So it will not pass. Only 4 cos 5t will pass. And this will also be multiplied with the magnitude of h of omega at omega equal to 5. Right? Input frequency is this frequency only is passed. So at this frequency, what is the magnitude of this transfer function will be multiplied here. So can you tell me that at omega equal to 5, what is the magnitude? It is having a magnitude 1. So output will be 4 cos 5t. Okay. Output will be this one. Guys, these type of questions are very, very important. Regularly they are coming in GATE exam. Okay. And this is the concept behind them. This is how you can solve these questions. I hope it is clear. Okay. It's a very, very good question. Questions like this are coming every year in EC electrical exam. And this is the concept behind them. If you know this concept, you can easily get it done. Now what they can do, the input output is going to be calculated in the same way. They will modify the HT. Right? There your Fourier transform skills will be utilized. I hope it is clear. Then see this question. Question number 16. The Fourier transform of this signal will be what? We have to calculate the Fourier transform of this signal. So are you going to apply formula? If you are going to apply formula, it is going to take a lot of time of yours. Then what is the way? How to do this question? How to solve this question? Okay. Chalo, if I write x of t signal, then what I will write for it? So see the flow of this signal. This signal is traveling like this. Okay. So just write this signal. So x of t will be, it is in the form of step signal. So we will have, just see, at -t the magnitude is 1. So we will write 1 u of t plus t. At 0, it is traveling a total distance of 2 downward. Downward means negative. Negative u of t. Then at t, it is again moving up. Up means positive. How much it is moving? It is moving plus 1 u of t minus t. So what we can write? We can write u of t plus t, 2 of ut plus u of t minus t. This is x of t. Now just differentiate it, d by dt of xt. So differentiation of unit step signal will give you impulse signal. So you will get something like this. Okay. Now impulse signal has Fourier transform 1. Okay. And del of t minus t naught, what is the Fourier transform? E to the power minus j omega t naught. Del of t plus t naught, what is the Fourier transform? E to the power plus j omega t naught. Use these formulas. And what is the Fourier transform of differentiation? It is j omega x of omega. And what we will get here? E to the power minus e to the power plus j omega t. Right? This will be only 2. And here you will get e to the power minus j omega t. Right? This is what you are getting right now. Now after that, see what we can do. We can write e to the power j omega t plus e to the power minus j omega t, and we can divide by 2 and we can multiply by 2 minus 2. So this is a formula of cosine, 2 cos omega t minus 2 we can write here. Okay. After that, you can take 2 minus 2 common, so it will become 1 minus cos omega t. Okay. And 1 minus cos omega t is sine square omega t by 2. Right? Minus 2. We will get 2 sine square omega t by 2 here. Correct? So see, after that, write it x of omega. This will become minus 4 sine square omega t by 2 and divided by minus j omega. Right? J omega. Then j will go up and it will become minus j. So you will get 4j and sine square omega t by 2 divided by omega. Okay. And just see, after that you can do this thing, that x of omega, just multiply t by 2 and divide by t by 2. Okay. So if you are multiplying with t by 2 and you are dividing by t by 2, okay. So after doing this, what you will get? After doing this, just see, this will become the formula of sample. Okay. And what is 4t by 2? T is 2 pi by omega. Right? Just see, 4t by 2, or it is 2t, or it is 2 into 2 pi by omega. So what you will get is 4 pi by omega. Right? You will get 4 pi by omega. 4 pi by omega into j, and this will become sample square omega t by 2. Okay, 4 pi j by omega sample square omega t by 2. Acha, we have done a lot of things here. That many things are not required, guys. They want answer up till this step only. Just see. You got your answer in this step only. They don't want us to represent in sample. We have done that extra bit. They want answer in only sine square. So just see, we got our answer here only. 4j by omega sine square omega t by 2. Right? So this is going to be the answer. Right? If suppose they are asking in terms of sample, you can convert them in like this. Okay, so see, what you have learned from this question is that instead of writing the waveform and then using the formula, if we differentiate, it will become very easy for us. Okay, and remember two things in sine signals. Whenever you have seen cosine sine, expand them into their exponential formula. Whenever you have seen exponential, convert them back into their sine cosine formula and then try to make sample. This is a normal trick in signal and system. This is a hint also how to approach for the problems. Correct? So I hope this question is clear. Okay. Then see question number 17. In question number 17, they have given x of t is this signal. The value of x of omega at omega equal to 0, and the value of this integral will be what? Right? What is the value of the x of omega at omega equal to 0, and the value of this integral is what we have to calculate. Okay. So see the signal. We have x of t equals to 2 sine 6 pi t upon pi t cos 2 pi t. Right. So x of t is 2 sine 6 pi t upon pi t into, let me write it here, x of t is 2 x of t is 2 sine 6 pi t over pi t into cos 2 pi t, right? So what you can do, multiply and divide by 6, then it will become 12, and sine 6 pi t upon 6 pi t will be sample 6 pi t into cos 2 pi t. Right? This is how we can write this signal. Correct? This is how we can write this signal. Okay. After that, again the same thing. Wherever we will see sine and cosine, the first thing that we have to do is expand them into their exponential formula. Right? The moment you will do that, you will get 6 sample. The moment you will do that, you will get 6 sample 6 pi t into e to the power j 2 pi t, right? Plus 6 sample 6 pi t into e to the power minus j 2 pi t. Correct? So this is what we will get. Okay. Now after that, calculate the Fourier transform of 6 sample. The Fourier transform of 6 sample 6 pi t. So the Fourier transform of 6 sample 6 pi t will be what? It will be a rectangular pulse in the frequency domain. Okay. A rectangular pulse in the frequency domain from minus 6 pi to plus 6 pi, and what is going to be the magnitude? A pi over k, right? A pi over k, where a is 6, pi is pi, k is 6 pi, so you are going to get 1. Okay, so we can write here 1, right? Now if suppose I have multiplied 6 pi t, if I have multiplied this signal with e to the power j 2 pi t, okay, then what will happen? If you have multiplied this signal with exponential, then frequency will be shifted by 2 pi, Okay, so see, this is the shifting amount and exponential is positive. So shifting will be negative shifting. So it will shift towards the right direction. So what will be the signal? The signal will be shifted by 2 pi in the right side. So you will get it like this. Minus 4 pi to 8 pi and 1. Okay. Then if I have 6 sample 6 pi t e to the power minus j 2 pi t. Then what will happen? The same will be shifted towards the right side. Okay. Sorry, towards the left side. Shift it towards the left side. So you will get minus 8 and 4. Right. Let's suppose that this is h1 omega and this is h2 omega. Okay, now what we have to calculate is, let me write x1, x2, not h1, h2. In this way, just see, you have calculated the Fourier transform. Correct? Let's suppose you have broken this signal xt into these two signal x1 and x2, and this is the Fourier transform. Now what we have to calculate is, we have to calculate x of omega at omega equal to 0. So x of omega at omega equal to 0 will be what? So get x of omega. So what will be x of omega? X of omega will be the sum of these two signals. Okay, just let me just sum them up. So total signal will be from minus 8 pi to plus 8 pi. Okay, and I have to add these two. So from minus 8 pi to 4 pi, the magnitude will be 1 and then it will become 2. Just like this, 1 and this is 2. This is going to be your x of omega. Right? x1 omega, x2 omega added together because x1t plus x2t was there. So x1 omega plus x2 omega will be here. Now from here, can you tell me that what is the value of x of omega at omega equal to 0? So clearly this is omega equals to 0. The value is 2. So answer is this one. And then we have to calculate this integral also. Okay. We have to calculate this integral also. What is this integral? This integral means you have to calculate the energy. Right? This integral means you have to calculate the energy. So Parseval's theorem will be used. Parseval's theorem says that energy of xt, or which can be written by this integral, right, is equal to 1 upon 2 pi minus infinite to plus infinite x of omega square d omega, right, or 1 upon 2 pi area of x square omega, right, area of x square omega curve. So this is x of omega. What is x square omega? What is x square omega, guys? So energy of xt, or this integral, will have a value 1 upon 2 pi, right? See, a square b is used to calculate. You have to square the magnitude, okay, and you have to multiply with the width. So from minus 8 pi to 4 pi, the width is 4 pi, magnitude is 1, square of 1 will be 1 square into the width 4 pi. Okay, from minus 4 pi to 4 pi, the width is 8 pi, magnitude is 2, 2 square will be 2 square and the width is 8 pi. Okay, then again for this duration, it is 1 square into 4 pi. Okay, then what we are going to get? 4 pi, 8 pi, and this is going to be 32 pi. So we will get 40 pi divided by 2 pi, and this will give me 20. So this is going to be the answer, right? This concept has used two things here: how to calculate the value of x of omega at omega equal to 0, and how to calculate the energy of the signal. Okay, any one of them can be asked. In last question you have only calculated you have used the Fourier transform of sample signal. See here, right? Here you have sample signal multiplied with cos also. So how to deal with the sample signal multiplied with cos also, that also you have seen here, right? This is the only modification that the gate authorities can do. Either they will give you a normal sample signal, or they will multiply a cos with that. How to deal with that you have seen through this question. Okay, the learning will help you in solving many other questions. I hope this is clear, guys. Correct. Now let us solve another question. Question number 18. Now see this question. Xt is given in a different way. What we have to tell here is that what is going to be the Fourier transform at omega equal to 0, right? In last question also we have calculated the same thing, but here xt is modified. So how to deal with a question like this? Have a look. We have x of t, which is sine 2t upon, we can write t into sine t by 2, and we can write t. Okay, like that we can divide. Now here let me multiply with 2 and 2 here. Okay, and here let me divide by 2 and 2 here. Then the same thing will become 2 sample 2t, right, into 1 upon 2 sample t by 2, right? And this 1 by 2 and 2 will be cancelled. So you can simply write it sample 2t into sample t by 2, right? This is your signal x of t. I can also write it like x1t into x2t. Okay, now x1t into x2t. Got it? So we have multiplication of signal. Related to multiplication we have a property. Multiplication of signal in time domain is equal to convolution of the signal in frequency domain, right? Convolution of the signal in frequency domain. So see, what is x1t? X1t is sample 2t. Let us take the Fourier transform. So the Fourier transform of this signal will be what? Fourier transform of a sample signal is a rectangular pulse in frequency domain from -2 to 2. Okay, and what will be the magnitude here? A pi over k. See, a is 1, pi is pi, and k is 2. So we will get pi by 2. Okay, so this magnitude is determined by a pi over k, and this will be pi by 2 here. This is x1 omega. Correct? Similarly, x2t, which is sample t by 2. What is going to be the Fourier transform of this signal? So the Fourier transform of this signal is again going to be a rectangular pulse. Right? Rectangular pulse from -1 by 2 to +1 by 2. And if I calculate the magnitude a pi over k, right, then what is a pi over k? A is 1, pi is pi, k is 1 by 2. So you will get 2 pi. Okay, so this is going to be 2 pi, and this will be x2 omega, right? See, we have multiplication in time domain. Multiplication in time domain is equal to convolution in frequency domain. Okay, so we have to do the convolution of these two pulses, right? Convolution of two rectangular pulses of unequal duration will be a trapezoidal pulse, right? So see, we can write this result as 1 upon 2 pi, and what we are going to get as a result is a trapezoidal pulse. Right? So convolution of these two rectangular pulses will be a trapezoidal pulse. How I will draw? Left hand coordinates are -2 and -1/2. Add them. -2 and -1/2 will be what? 2 plus 1/2 will be what? 2.5. Okay. So the extreme left will be -2.5. Similarly, extreme right will be 2 plus 0.5. So extreme right will be plus 2.5. Okay. Now from here, just count the distance T1. Right. T1 will be the lowest of them. So see, which one is lower here? 1, and what is T2 here is 4. Okay. So from here, travel just distance 1. So this point will be 1.5. So here your ramp will become what? It will become a step. Right. Now T2 you have to measure from here, and T2 is 4. So you will reach here up till 1.5. Okay. And just like this you will move. And what is going to be the magnitude? Magnitude is A1, A2 into the lower distance. A1, A2 into T1. Up, can you tell me what is going to be A1, A2 and T1? What will be the value of magnitude A1, A2 and T1? This is going to be x of omega. A1 is pi by 2 into 2 pi into T1 is 1. So you will get pi square. Okay. Now see what we have to calculate. We have to calculate, this is your x of t. Okay. And this is your x of omega. We have to calculate x of omega at omega equal to 0. So see here, you already have 1 by 2 pi out. And what is x of omega at omega equal to 0? What is x of omega at omega equal to 0? This is omega equals to 0. At there you have a value pi square. So final answer will be pi by 2 or 1.57. Right? See, this was a very important and very good question where you have utilized the concept of multiplication in time domain is convolution in frequency domain. Then convolution of two rectangular pulses is a trapezoidal pulse. Right? And this is how you will get that trapezoidal pulse. And finally, what is the value at omega equal to 0? This is a very good question which can come in GATE exam at any time. Right? Which can become the part of GATE exam, guys, at any time. Right? I hope you have understood. Rectangular of two pulses, convolution of two rectangular pulses is a trapezoidal pulse. Okay. This distance is T1. This distance is T2. We have solved many questions related to this concept. So I hope the concept that I want you to practice and I want you to be prepared are done. Then see this question. Question number 19. Consider the signal xt whose Fourier series representation is represented like this. What is the nature of the signal? Okay. So what is an ideal Fourier series representation? K is minus infinite to plus infinite. Ck e to the power jk omega naught t. Right. So from here we can get this Ck, and Ck is cos of k phi. Now look at this Ck. If you look at this Ck, then this Ck is what? This is real because there is no j present, so it is not imaginary. This is real, plus cos signal is an even signal. Right? So we know that if xt, then what is Ck? If Ck is real and even, then xt was also real plus even. Correct? If it is imaginary plus even, then it will also be imaginary plus even. If it is real plus odd, then this will be imaginary plus odd. If it is imaginary plus odd, then this will be real plus odd. So what we have in our case, that Ck is real plus even, so Xt will also be real plus even. This will be the answer. Knowledge of this table can also simplify the things. Okay, so prepare this one. This is the objective of taking this particular question. Okay, I hope it is clear. Then I am giving you this question as homework, right? I am giving you this question as homework question because this is related to question number 19, question number 18 that we have done. So I want you to solve this question, right? I want you people to solve this question. Okay, and when we will meet in the part 2, if you people will be having doubt, we will discuss this question, solve this question. The answer of this question is 0.636. Answer of this question is 0.636, right? What is there in this question? Xt is a result of convolution of these two signals, and these two signals are given. So you can convert this signal into a sample signal, which will become 2 sample 2t, and you can convert this signal, this will become 4 sample 4t. Okay, now take their Fourier transform. They will be having rectangular pulses of unequal duration. Convolution in time domain is multiplication in frequency domain. You will get one rectangular pulse from here, one rectangular pulse from here. You have to multiply them. Multiplication means obtaining the common thing. Then you will get the final x omega. You have to find the value of this integral. So apply Parseval integral 1 upon 2 pi integral x omega square. You already had x omega. Okay, by taking the common part of this waveform, you can easily get your answer. Okay, so this is an easy question which I am giving you as homework because we have solved many questions like this. Correct? So I believe you can do that. Now see this question, and this is going to be the last question for this part, right? What is the value of this integral? Let us find. Value of this integral h of omega is given 9 minus omega infinite to plus infinite sine omega by 3 upon omega whole square and d omega, right? So let me multiply with 3 here and divide by 3 here. If I am going to do that, then what I will get is 9 minus infinite to plus infinite. 1 upon 3 square will be 1 by 9. Okay, that I can take out. Sine omega by 3 upon omega by 3 square d omega. So 9 and 9 will be cancelled. Minus infinite to plus infinite. Sine theta upon theta is sample theta. So it will become sample omega by 3 square d omega. Okay. Now, if we have sample in time domain, we very well know what to do. But if sample is present in frequency domain, then what to do? Right? If sample is present in frequency domain, then what to do? So I can write it minus infinite to plus infinite. Let's suppose that it is some x of omega square d omega, right? That means that x of omega is what? It is sample omega by 3. Okay, x of omega is sample omega by 3. So now we have sample in frequency domain. If sample is there in the time domain, we have solved many questions like this. If sample is there in frequency domain. So if time domain is sample, frequency domain is rectangular pulse. If frequency domain is sample, time domain will be a rectangular pulse in time domain. Okay. So remember this, that if I have a rectangular t by tau signal, then its Fourier transform is a rectangle, its Fourier transform. If I have this rectangular pulse, see, if I have a rectangular pulse in time domain whom I can either draw or I can express in terms of a rectangular t by tau also. Okay, so if suppose you have this signal, then frequency Fourier transform is a tau sample omega tau by 2, right? So if Fourier domain, Fourier frequency domain is sample, time domain was rectangular pulse, right? Up by using this property, right, by using this property that I have written here, just see that what we can do with this problem. So in our case, what we have, in our case we have x of omega, which is sample omega by 3. Okay, match it with this. So what is there for a tau? It is 1. And what is there for tau by 2? It is 1 by 3. So tau will be 2 by 3. So a will be 1 upon tau, or it is 3 by 2. Right? So that means the inverse Fourier transform, if I take, it will be a rectangular pulse, right? It will be a rectangular pulse of like this. What is tau by 2? It is 1 by 3 minus 1 by 3. What is a? It is 3 by 2. Okay, this is the signal x of t, right? Up see, we have this integral to evaluate. Okay, up by using Parseval's theorem, okay, by using Parseval's theorem, energy of xt, which is minus infinite to plus infinite, x of t square dt is equal to 1 upon 2 pi minus infinite to plus infinite x of omega square d omega, right? So from this, suppose that if I have to calculate that what is going to be minus infinite to plus infinite x of omega square d omega, then this is equals to 2 pi into energy of the signal xt, right? So what is the energy of this signal? Can you tell me? The energy of this signal, this is a rectangular pulse, okay? So energy of this signal is equals to a square into b, where a is the magnitude 3 by 2 square into b is the width, which is 2 by 3, right? So how much will be the energy? Is it 3 by 2? Correct. The energy is going to be 3 by 2. I think it is not visible. Energy is going to be 3 by 2. Okay. Then guys, you can come in this formula and you can write here 2 pi into 3 by 2, or it will become 3 pi. 3 pi means 9.42, and this is going to be the answer, right? This is how you can solve this question. So what is the objective of taking this question? You have seen that if sample is there, frequency domain will be a rectangular pulse. Similarly, if frequency domain is sample, the time domain will be a rectangular pulse. So we are getting something like this. Then by utilizing this concept, okay, we found that the time domain will be a rectangular pulse, and what we have to calculate is nothing but 2 pi times the energy of the signal in time domain. It's a rectangular pulse, finding energy is very easy, and then finally you will get your answer. Correct? So this is how you can solve these questions. All these 21 questions were the fantastic questions. They have given you some very good concept. Guys, if you will practice these concepts, you can do any question in GATE exam. And this is just the part 1 of signal that I have taken, right? Wait for the part 2. I have some very good question from other topic also. Some Fourier transform, Laplace transform, jet transform, DTFT, DFT. I have some very good questions that I will cover in part number 2. If you are watching this part 1 and part 2, entire signal will be revised with some very good question and very good concept that you can expect in the upcoming GATE exam. So I hope that you really like this video. Okay. Do not forget to share this video amongst your friend group, right? And if you really like the teaching and learning of IMS GATE Academy, you can join our live online program for GATE 26 or 27. Okay. With some very good features that we are offering that you can see here. You can book a free counseling session with us, right? This is just a crisp of the things that you have seen in this video. If you want to, if you will join us, your learning part will be very good with us, right? So if you wish to join us, you can book a counseling session by calling on these numbers, and you can also join our test series, right? And this is the schedule of the test series if you are preparing for GATE 26, which will help you. Okay, so we have some very good question in that test series as we have discussed here in this session. These are the toppers that we have produced in GATE 25. Right now they are at IISc, IIT Bombay, IIT Madras, IIT Delhi, right? Similarly, we had toppers in 24 also. You can become the next topper also. So join IMS GATE Academy in your GATE journey, and we will help you in achieving your goal. So thank you so much for watching this video. Now I will come in second part. There I will discuss some other topics of signals and system. So stay tuned to our channel as well. Thank you so much.